Hey folks, okay, I want to go through a design and implementation problem here where we're given a problem that we have to solve. We'll think about what kind of a design we want to go with, and we'll plan that out, we'll consider some of our options, and then once we've settled on that, we'll come up with an implementation approach, and then we'll gradually refine that and build the elements out incrementally. So we'll take a kind of a more interesting problem and we'll just follow it through from beginning to end and see where we go. So in this case, suppose our problem is as follows. We've got a list of circles that we have to keep track of in a 2D plane. So each of them is going to have an x-coordinate, a y-coordinate, and a radius. And so we're trying to keep track of all these circles on an xy plane. Now, we're told that we need to be able to keep the circles in order, so the order they were given to us, we have to keep track of that. And they could add more circles at any time, so this list of circles can grow over time. We need to be able to add a single circle, we need to be able to print the circles, but within a specific size range. So the user can say, show me all the circles of sizes 10 to 15. Show me all the circles of sizes 0 to 1. So the user is able to go through and say, okay, show me these specific circles, these circles with a particular size to them, or size range to them. So we have to think about the approach that we're going to take. Again, we've got this list of circles. Somehow we're going to have to settle on a representation for our circles, and somehow we're going to have to store them. Again, we can think of this either from an array-based point of view, or maybe a linked list approach. Right? This is the same sort of problem as we ran into in the earlier example we were looking at with ADTs. Is, well, what would be the trade-offs between them? Again, an array is a simpler approach, but a fixed size array is a bit of a problem if we don't know how many circles we're going to wind up with. And if we have no idea of what kind of a range we can deal with here, then we're stuck with the problem. Okay, well, I might pick a size that's too small, and if I pick a big size, that might be too big most of the time. So perhaps we decide to go with a linked list style of approach where I can create a linked list of circles, and I can add one more circle to the end of the chain anytime I want. And again, so this might be the approach that we decide to go with. And we need to think about, well, what kind of information am I going to work with? Right? Our circles are going to have an x value, a y value, and a radius associated with them. So it seems like a struct would make a reasonable implementation choice. Now, particularly as we haven't got to classes yet. So we'll think of this idea as we'll have some kind of a struct representing our circle with fields for the x, the y, and the radius. And if we're going with a linked list style of implementation, then we'll also add a pointer field for the next circle in the list. For our program overall, it's going to help if we can go through and identify the beginning and the end, so that I've got the front, so I can keep track of when I want to go through and print the list from beginning to end, or to go through and find the circles in the order they were entered. I've got to be able to start from the beginning, but I'm going to want to do lots of inserts at the end, which is going to be a lot easier if I have a pointer to the end as well. So for my overall implementation, I'll keep track of where the front is and where the back is, and I'll have this linked list of structs in between. Now, what am I going to need if I'm going to work with my circles? Well, I'm going to need a routine to go through and create a new circle. So maybe you give me the x, the y, and the radius, I'll create a new circle for you. I'm going to want a routine to go through and add a new circle to the end of the list. I'm going to want a routine that takes care of my search and print. So you give it the front of the list and the size range that you're interested in, and it goes through and prints out all the circles that are in that size range. So those are the three kind of functionality pieces that the user has asked for. What else am I going to need in order to support this? Because I am going to need more kind of administrative functions to make all the rest fit together. Well, I guess if I should decide on the overall structure of my circle. So maybe I'll go with doubles for x and y and radius. They haven't told us what kind of precision we need, so maybe we'll go with that as giving us the best possibility of covering our bases. Now in terms of support functions, well, we've got our create function we should settle on. So create, if this is going to go create a new circle for us, we'll return a pointer to the circle we're creating. You give us the x, the y, and the r. For insert, you give us the circle and you give us a pointer to the end of the list and we'll insert there. And we'll make that by reference so that we can actually change it. Now, maybe the insert doesn't work for some reason, so we'll return a true-false value as to whether that worked or not. And again, we'll need a search function. You tell me where the front is so I can start there. You tell me what the range of values, what is the range of values you're looking for, and I'll go through from beginning to end and just print out the circles that I find. I'm going to need to be able to get some kind of a choice from the user as to what they want to do next. Right? The user's got this possibility that they can add something new to the list or they can search the list. So I need to be able to identify what they want to do now. And maybe I also need to give them an option as to when they're done. Right? So maybe I'll come up with a quit option, an insert option, and a search option. And so I've got to have some way of getting those commands from the user. So again, I've got to think about, well, what kind of an approach am I going to take? Maybe I'll take represent characters for those, and I'll just prompt the user, tell me what you want to do, quit, insert, or search. And they'll give me back a letter, and I'll use that as the basis for what to do next. So if that's the case, I need a function to go through and get the next command from the user. So I'll set up some constants for my 3 command characters. And again, if I use the constants, then if I decide to change my mind about these later on, I can change which specific character it is. I'll have a get command function that's going to return whichever one they picked. And maybe I'll have this take care of invalid commands, so it keeps repeating until they make a valid choice of one of those 3 things. What else do we need? If I'm going to go through and allocate things and create things and add them to this list, then I should clean it up when I'm done. So for the very end of the program, I'm going to want some kind of a deallocate routine that goes through the list of circles and gets rid of them all. If I'm asking the user to enter numeric values for x and for y and for the radius, then I probably want a function that can read a number from the user, make sure it's actually a number, and repeat until they give me something valid. So maybe I'll come up with a getNumber function. And so that's going to prompt the user and get the value, error check it, keep going till it's right, and then return the value. I'd like to be able to use this function for all 3, to be able to use the same function to get a number for x or for y or for the radius. So maybe I go through and give them a prompt. I take a prompt as an extra parameter saying, okay, use this to go through and specify what you want. Enter x or enter y or enter radius. So some kind of a prompt that tells them what specific kind of number I want this time around. And then I'm going to take an incremental approach to going through and building these things. So I'm going to implement a small chunk and compile it and test it, and implement another small chunk and compile it and test it to make sure that I've got kind of localized debugging issues at any given point in time. So in the beginning, I'm just going to create kind of skeletal versions of everything. The struct that I'm going to use for my circles, the functions that I want, the main routine. So essentially no bodies to any of these things, just the basic structure, and compile it and make sure that I've got my function definitions right. And once that's done, I'll set up the main routine to call all the functions the way I think main should work. And then I can go through and start implementing the functionality for the individual pieces, right? A function to go through and process whatever the current command is, a function to get the command, a function to get the number, a function to create a circle, to insert a circle, to search, to deallocate. I'll just go through and implement these beasties one at a time. So again, I'm just going to go through and taking that first step, just put together the definitions that I'm going to use, the definition for the struct, the prototypes that I'm going to use, just the bare bones structure of this thing with no meat to any of the functions yet. So again, we're taking the, whatever I think I'm going to need in the way of libraries and namespaces, my definition of the circle struct, the 3 commands I settled on for quit, insert, and search, and then the prototypes I arrived at for those different functions. And I'll go through and create empty bodies for all of the functions for now. Right, just an empty main, an empty create, an empty insert. I've stuck return values in a couple of these if they've got return types with just some default chosen return value for now. And I'll replace that with the real bodies once I get there. For now, I just want to make sure this thing compiles and that I've got all my prototypes right and all my function implementations correct. So my parameter lists match up, that kind of an idea. So at that point, I compile, test, debug anything that I've stuck in here that's syntax errors, and then move on and start implementing things. So I decided I wanted to do the main routine first. Well, if I'm going to implement my main routine, then what do I want it to do? I need my pointers for the front and the back. So I'll start off with those both null to indicate that the list is empty in the beginning. I'm going to want to be able to get commands from the user over and over and over again. So those were characters, so I'll have a character for my command variable. And then I'll have some kind of a do-while loop that keeps processing commands until eventually the user decides to quit. So I get my do-while loop, and then I worry about the guts inside. Well, what do I want to do inside? I want to get a command from the user, and that's supposed to go off and keep going until they give me a valid command. So I'll trust that that's going to work. And then I want to do either an insert, a search, or a quit. Well, if the command is an insert, what do I want to do? I want to get the x value, the y value, the radius, create a circle, and then try and insert it. So I'll do exactly that. I'll have variables for my x, my y, and my r. I'll call get a number and say, enter x to get that, get a number of y, get a number, enter radius, get those 3 values. Call my create function. It's going to give me back the circle that I want to insert. Check that that's not null because, again, things could go wrong in trying to create it. And if everything goes okay, then I'll try my insert. Right? So, okay, well, insert, here's a pointer to the front, here's a pointer to the back, here's the circle I want to insert, go do it. I can go through and handle the searches. If the command is a search, well, what do I want to do? I want to know the minimum radius, the maximum radius, and then go through and do my search. Right? So I can set up variables for my min and my max, use get a number to prompt the user to enter a minimum radius, enter a maximum radius, try a search based on those. And again, this gives me the basic structure that I want for my main routine. And at the end, when it's all done, I want to deallocate, just go from the front on, deallocate every circle in there. So again, at that point, I'm going to turn around and say, well, none of these do anything yet, but I can compile it and deal with any syntax errors I've got in here, any places where I've forgotten to declare a variable or where my types aren't right or where I've messed up the parameters that I'm passing. So I can go through and compile and get the basic structure of this. Now, if I've set up my, can't remember if I did, but if I've set up my get command to return quit as the default in the kind of just basic skeletal version, I can even run this because the command is just going to say quit, and the very first time through it's going to quit. So I can do a basic functionality test at this point as well. Right? But once I've got that, then I can just go through and start actually entering or completing my functions one at a time. And go through and complete my get command. Again, the idea is we want to prompt the user, right? Tell them to insert, search, or quit, and tell them what the right character is for each of those. Read it in. Maybe convert it to uppercase so that I can just handle, they can enter in uppercase or lowercase and I can accept either. And then either they gave me a valid command or they didn't. So if it's an insert, a quit, or a search, it's valid and I'll return it. If it's anything else, then I'll tell them that was an invalid command, try again. I'll call get command again and return whatever it gives back. So I get this kind of recursive structure to eventually get me a valid command. Now again, at this point, I can go through and compile and test and make sure that this actually works. And again, deal with any syntax errors or any bugs I've introduced in my get command. So we just plow right ahead. I write a function to get a number. Okay, well, we've done this lots of times before, right? They're giving us a prompt that we're supposed to show to the user. And so we'll display the prompt. we've got a variable for the number. We'll try and read it in, see if it fails in case they enter garbage, and if they do enter garbage, we'll clear the fail status, skip over the garbage, tell them that wasn't a number, try again, and do a recursive call to try again. And eventually, we return the valid number that we get back. So again, at this point, I can compile and test and make sure that things are going okay so far. My create function, right? I want to be able to create a circle. So they're giving me an X, a Y, and an R. I'm going to allocate a new circle and return a pointer to it. Right? So I can call new on circle, get my pointer to this thing. It might not work. So if it's not null, if it actually gave something back, then I'll set the X, the Y, and the radius values. And at the moment, I'm going to set its next pointer to null because I don't know of anything after this. So we'll have, just for safety's sake, we'll make sure that we start this off at null initially. And we'll return whatever pointer we wound up with. It's either going to be null because the new failed, or it's going to be this value that we've been given, that we filled in. Right? And again, at this point, I can go through and compile and test and make sure that this works. Insert. Right? If I'm going to go through and start adding things to the list, well, they're giving me a pointer to the front, they're giving me a pointer to the back, and they're giving me a pointer to the new thing to insert. Now again, if they gave us, if they pass a null pointer along here because the create didn't work, then we'll return false and say, no, I can't insert that. I'm not inserting null circles into my list. But if we get past that, there's two possibilities. Either this is the very first circle being inserted, in which case front and back are both null at the moment, or it's a later circle in the collection. So if this is the very first one, front is going to be null so far, and so this is going to be both the first and the last thing in the list for the moment. So we'll just make front point to it and back point to it, and we'll return true. Okay, we're done. Otherwise, this is something that's going at the back of the list. There's already at least one thing in there. So the thing that used to be the back, we want to make sure that it now knows that the new circle is coming in after it. So we set backs next to the new circle. And then we want to make sure that back now recognizes that the new back of the list is this new circle. So backs set to new circ. And we can return true. So again, insert should now hopefully be working. We can compile that and test that so far. Our search function that's supposed to go through and find circles within a given radius. Again, we're being given a pointer to the front of the list, the smallest radius to use, the largest radius to use, and we'll just start at the front. And as long as the one we're on right now isn't null, we'll see if the current circle is a valid one to print out. So if the current circle's radius is greater than or equal to the smallest value, and its radius is less than or equal to the maximum value, then we'll print it out, right? We'll print out the X and the Y coordinates and the radius. And, ooh, nasty, nasty, nasty. We're forgetting here to move on to the next circle in the list. So we should also here say current is equal to current next, right? That would belong right after our if statement. So the last thing in the while loop should be to say, well, current is equal to current next, so we move current along to point to the next thing in the list. So I've got to go back and update my slides here. So this is one of the things that we discover when we compile and test, and we try and search, and it goes off into an infinite loop. If the first circle in the list happened to be one that it was supposed to print, it would just keep printing it over and over and over and over and over and over and over again because it's never moving on to the next circle in the list. So we do need a current equals current next in here. All right, and the one thing we had left to deal with was cleaning it up at the end. So our deallocate routine that's supposed to delete everything that's in the list. Same sort of idea. They give us a pointer to the front thing in the list, and as long as it's not null, we'll remember the front, the one that's currently in front as the victim we're going to get rid of. We'll move front along to point to the next thing in the list, and then we'll delete the one we wanted to get rid of. And again, this will cycle through until eventually it hits the null pointer at the very end. So again, we've got our deallocate, we can compile and test, and hopefully the whole thing should be working by this point. Assuming that we've actually fixed any of the bugs that we ran into at our various compile and test points. All right. Again, that's kind of the style of approach I would take for a problem like this one. Hopefully that made sense. I welcome folks to go through, and obviously I haven't actually compiled and tested this, so I think that would be a good exercise if you're bored and you've got some time to kill and you want to practice with this stuff. Go through and actually try compiling these, running these, testing these, and seeing where the flaws are in it, because there's undoubtedly one or two that are either syntax errors or parameter errors, or things like the that little glitch in well, not little glitch, that glitch in our search routine. All right, I will leave it there for now.